Problem number 52, part A. In figure, what value must R have if the current in the circuit is to be 1.5 milliampere? Take the first EMF, which is equal to 2 volt, and the second EMF, which is equal to 3 volt, and the internal resistance small r1, which is equal to small r2, which is equal to 3 ohm. So here in the first part of the question, we are going to find what should be the value of this capital R. Caps R value we are going to find. And in the second part of the question, what is the rate at which the thermal energy appears in R? So here in this external resistance, how much power generated? So we are going to find the value of the power in the second part. So we just work out step by step. So first of all, I'm going to solve the part A question. So we just write the given first. What is given in the question? The first battery EMF is given. So what is the EMF of the first battery? The EMF of the first battery is 2 volt, and the EMF of the second battery is 3 volt. And the internal resistance of each battery, each EMF, R1, small r1, which is equal to small r2, which takes the value of 3 ohm. And in the first part, we are going to find what should be the value of the external resistance caps R. Now, if you want to find the answer for this caps R, you have to apply the loop rule or Kirchhoff's voltage rule. So what you studied in the theory, the algebraic sum of the EMF, which is equal to the algebraic sum of the product of the resistance and its respective current. So we are just going to apply that rule. So one side, I'm going to take all the EMF, and another side, I'm going to take the product of the resistance and its respective current. And the most important thing, if you have two batteries, and you have to see which one is the strongest battery. And also the diagram clearly tells, so E1, the current flow is from the positive, so it will be going in this direction, but in the E2, the current will be moving in this direction. But the most important thing, you have to see the value of EMF 1 and 2, and you have to give the priority to the strongest one. So here we have the EMF 1 and EMF 2 value, but if you see the E2 value is greater, which is equal to 3 volts. So what I'm going to do, I'm going to consider the direction of the current will be in this direction. So I am going to take the direction of the current in this direction. Why? Because the EMF value of the second battery is stronger, so I am going to consider the direction of the current is this one. So I have to apply the loop rule here. So first of all, I'm going to separate the EMF. So how many EMF we have? We have EMF E2 and EMF E1. And here EMF 2 is the greatest, so it takes the positive value. So E2 minus E1. Why it is minus? Because you can see this is opposite to this direction of the current. And also this is weaker. So here E2 minus E1. So I separate the batteries one side. And in the right hand side of the equation, I'm going to multiply the current and its resistance, the product of the resistance and its respective current. So let's take. So this current is initially, it is going to enter R1. So when this current I enters this R1, so you have to multiply. So that means the current multiplies. So in the right hand side of the equation, I'm going to write the product of the resistance and its current. So when this current enters this R1, I have to write I multiply by R1. Likewise, this current, again, it will be going to enter the external resistance R. So I have to write, so current I multiply by caps R. And this current is again going to enter the internal resistance R2. So plus I multiply by R2. So that means in the left hand side, we separate the EMF. In the right hand side, we separate the product of the resistance and its current. So resistance and its respective current, we just separate both. So if you see the left hand side also, you have the EMF, right hand side also you have the EMF, because I multiply by R is nothing but voltage, and the unit for the EMF is voltage. Now I am going to simplify this equation, because we have the values for EMF 1 and 2, and also we have the internal resistance R1 and R2, all the values we have except caps R. So that means the external resistance value we are going to find. So what I have to do, I have to simplify this equation. So in the right hand side of the equation, the current is the common term, so I am going to take current as a common. So I multiply by R1 plus R plus R2. In the left hand side, it's EMF2 minus EMF1. Now I'm going to move, because if you see the left hand side and the right hand side, so what I'm going to do, I'm going to move the current, because we are going to find the value of caps R. So if you want to find the value of R, you have to keep this term here. I'm going to move only the current in the left hand side of the equation. By that, EMF2 minus EMF1 divided by current, which is equal to R1 plus R plus R2. Now what I'm going to do, we are going to identify this value. We are going to find the value of R. So I'm going to move this R1 and R2 to the left hand side. By that, the equation become EMF2 minus EMF1 divided by current. And when this R1 and R2 will come, both will take the negative value. So minus R1 minus R2, which is equal to R. So now I'm going to substitute the value. Let's see what are the values given here. And in the question, they clearly mentioned the value of EMF 1 and 2 and R1 and R2 values given. And also they gave the current. What is the current here? So current here is 1.5 milliampere. That means in terms of ampere, it is 1.5 multiply 10 power minus 3 ampere. So I have to substitute all this value here. So let's see what is the answer for this R. So EMF 2, it's 3 minus 2 over the current is 1.5 milliampere, so 10 power minus 3 minus R1 and R2 both are 3, so 3 ohms minus 3 ohms, which is equal to R. So I have to find the answer here. 3 minus 2 over 1.5 10 power minus 3. In this place I got this part. I got 666.67, and this one is minus 6, which is equal to R. So when you just minus R, so you will get the answer here as R, which is equal to 660.67 ohm. So we can just write in terms of multiplication for the power form. So therefore the resistance, the external resistance R, which is equal to 6.60 multiply 10 power 2. So this is the answer for this question. Either you can just leave the answer like this, or you can just convert this answer in terms of power. Both answers are right. Clear? So this is the answer for the part A. And in the part B, what we are going to find, so we have to go back to the question again. So in the part B, we are going to find what should be the power generated in R. So in the theory, we studied 3 rules for the power. What are they? Power P, which is equal to the current multiplied by EMF, and power P, which is equal to the current square multiplied by R. And also we have the rule EMF square over R. So if you see, we can't use these two, because only this question is easy. This formula is easy for getting the answer for the power generated at the external resistance R. So I'm going to use this formula. Therefore P, which is equal to I square multiplied by R. And what is the value of our I here, which is the current is 1.5 milliampere. So 1.5 multiply 10 power minus 3 the whole square multiply with the resistance, the external resistance just before we found in the first part, which takes the value of 6.6 multiply 10 power plus 2. So I'm going to multiply. Let's see what is the answer. 1.5 10 power minus 3 the whole square multiply with 6.6 10 power 2. So what's the answer? I got the answer here as 1.485 10 power minus 3, and the unit for the power is watt. So this is the answer for the part B. Clear? So this is the answer for both part A and part B. That's it. Thank you.